The easiest way to understand this is for you to take the long way in the beginning until you understand the shortcut, which is the laws of exponents. So for this one, it says that when you're multiplying exponents and the bases are the same, so let's take 5 to the third power. Let's use numbers. And you multiply by 5 to the second. Instead of giving me the actual answer in standard form, this in exponential form, well, we keep the base and we add the exponents, 3 plus 2. And that's the same thing as 5 to the fifth power, which is in exponential form. Now, let's expand 5 to the third power. That means 5 times 5 times 5. And 5 to multiplied, by the way, so we're continuing to multiply. 5 to the second power is 5 times 5. Now, if I were to ask you to rewrite this in exponential form, you would write 5 to the fifth power, which is the same thing we did up over here without expanding. So the shortcut is to add the exponents. I'll give you another example. 2 to the fourth power times 2 to the seventh power. Again, I don't want standard form. I don't actually want you to tell me what the value is, but just in exponential form, what would that be? Well, 2, the bases are the same. We're multiplying two numbers that share the base. They're both 2's. And the exponents, one has exponent 4, the other one has exponent 7. So the shortcut would be to add those two. And you get 2 to the 11th power. Now, if you were to expand this, and again, maybe you should do this in the beginning. 2 to the fourth power is 2 times 2 times 2 times 2 times 2 to the seventh power. I'm going to change colors here. 1, 2, 3, 4, 5, 6, 7. So that's what we're doing here. That's 2 to the fourth times 2 to the seventh. It's this whole thing here. No one wants to write that, right? No one wants to write that. So that's why we use exponent, which is just repeated multiplication. Now, to write this whole expression as in exponential form, well, you would tell me that this is just 2 to the 11th power. So that's what we're doing. And the shortcut is, if the bases are the same, add the exponents. That's it as far as this rule when you're multiplying two factors. So I know we said every multiple of 3, so take a look at the first one. It's a to the third times a to the fourth times a to the seventh times a, and there's a 1 here. So we keep the base, we add the exponents, 3 plus 4 plus 7 plus 1. That's going to give us a to the, let's see, 7, 7, 14, 15th power. That's the shortcut. And again, I know you're going to get tired of me saying this, but if you want to expand it, a to the third is a times a times a. A to the fourth is a times a times a times a. A to the seventh, a times a times a, 3, 4, 5, 6, 7. And then finally, this little guy here at the end, it's just an a. So again, look at this whole expression, and how do I write this? What's a shortcut? What's an exponential form? Because nobody wants to write a times a times a, all these repeatedly, but we rather write it in exponential form, and this is a to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so the 15th power. So whether it's variables or that could have been with numbers, it's the same thing. Okay. So 3, 6. So now, again, I think the writing is not that pretty, but let me write it to the slide. That says 5 times f times negative 3, and I'll put that in parentheses, times f to the third power times 2 times f. Now, because it's multiplication, the community property allows us to move. So if you feel necessary, you want to move the the coefficients all next to each other. So here's a 5, it's being multiplied by negative 3, and then multiplied by the 2. So if you want to rewrite the expression and have them all next to each other, go ahead. And then the f's, there's an f here, and f to the third, and then that last f here. That's what that expression looks. Now, all my variables on the right, all my coefficients on the left. So 5 times 3 times 2 is just 30, but it's going to be negative. F times f to the third power times f. Remember, we keep the base, add the exponents, and there's an exponent of 1 here, an exponent of 1. So it's 1 plus 3 plus 1, which is 5. So my final answer is this. Now, these are called equivalent expressions. They're the same thing, except that it's much easier to say negative 30 f to the fifth power than saying 5 times f times negative 3 times f to the third power times 2 times f. Ooh, right? Why say this when I can say that, right? 9. Again, I'll rewrite it. My guest. So again, we have a -2. Now put that in parentheses. We have a 4. And here there is no coefficient, but there's a 1 there. So I'm actually going to write -1. There's a 1 here. So I'm going to write -1. Be my guest. Now, my variables, I'll do it alphabetically. So I have a c to the 4th times a c to the 4th times a c, and then another c. Then I have a d, and then a d to the 2nd power times d to the 2nd power. Let's make that a little bit shorter. So -2 times 4 times -1. First of all, there's 2 negatives, right? So I know it's going to be positive. 2 times 4 times 1 is just 8. The c's is c to the, let me put a 1 here, let me put a 1 here, let me put a 1. C to the 4th times c times c. It's going to give me, keep the base, add the exponents, c to the 6th. And d to the 1st power times d to the 2nd power is d to the 3rd power. And again, let me take advantage. C to the 4th power is c times c times c times c. C to the 1st power is just c. And this c is just c. So again, if you were asked to write this in exponential form, we'll go back to your 4th grade class. C times c times c times c times c times c is just a short version of c to the 6th power. And d, and again, let me write that d over here, and then d to the 2nd power. If you expand it, it's d times d. So what is that? Repeated multiplication can be rewritten using exponents, and that's d to the 3rd power. That's all it is for this particular rule here. No idea what we just did. 9, so it's 12. So again, 3 times x to the 2nd power times, and I'm not going to rewrite this because eventually, hopefully you get used to not rewriting it. It's not necessary. If you want to, you can. Right, just now what are we multiplying? Let's do the coefficients. It's 3 and -3, so that gives me -9. Done. X squared and x to the 5th, keep the base, add the exponents, 2 plus 5, 7. Final answer. 15. I'll rewrite it. It's 12 times c to the 3rd power times 2 times g cubed times 4 times c times h. That's what that says. I mean, I know they don't put these little dots because it's implied, right? You know it's there, we just don't write it. Take care of the coefficients. The 12, the 2, and the 4, they're all positive, so that's just 96. Right? Let's do it alphabetically. C, there's a C, and there's another C. So c to the 3rd power times c. Remember, there's a 1 here. That gives me c to the 4th. So this c to the 4th. There's a g. That multiplies with no 1, so that's this. And there's an h. Now, you're not going to write 96 multiplied with that little dot in the middle times c to the 4th dot. So the actual answer is going to look like this. Right? That's what the actual answer is. So these little dots that I put in there, I mean, you can. Not necessary. 18. All right, so we're doing multiple of 3. 18. Again, I will rewrite it because so we have 2 times c squared times d squared times, I'll put the -5 in parentheses, times c times d to the 4th. Let's do them again this long way. Let's write it's 2 times -5, and that's -10. And then let's do the c. So c squared and this c. So you're doing c to the 2nd power times c. There's a 1 in here. Keep the base, add the exponent, so we get c cubed. Then we have d. And we have a d squared times d to the 4th power. D squared times d to the 4th power. That's d6. And again, d squared is d times d. D to the 4th power is d times d times d times d. If we were to rewrite this using exponents, that would be d to the 6th. And there we go. All right. So, and that's it for multiplication, right? If this is all the problem is asking you to do, our answer has no negative exponents, which is our goal. All right, so that we did multiplying exponents. The next one, again, dividing exponents. We're going to do all multiples of 3's again. Dividing exponents. Sorry, right here. Now, Division can be written in two ways. So let me just clear the air. So let's do, I don't know, 5 to the 4th divided by 5 to the 2nd. Let's take that example. If multiplication, we added the exponents, in division, we're going to subtract the exponents. So the quick way to do this is 5 to the 4th power divided by 5 to the 2nd power. Well, we subtract the exponents, we get 5 to the 2nd. Let's do a proof here. What's 5 to the 4th? Okay, think about what 5 to the 4th is. Hang on a second. 5 to the 4th power is 625. 5 to the 2nd power is 25. And 625 divided by 25 is 25. Isn't 25 the same thing as 5 squared? Right? So again, we're not asking you to change it to standard form. We're just asking you to do the problem and leave it in exponential form. All right, so that's that. So now I'm going to take that same problem and I'm going to write it over here, but it's a fraction. So 5 to the 4th power divided by 5 to the 2nd power. Well, you're going to get the same thing. Well, we should get the same answer, right? So think about, let's expand this. 5 to the 4th power is 5 times 5 times 5 times 5. And 5 to the 2nd power is 5 times 5. Now, I can simplify this 5 with this 5. 5 divided by 5 is 1, so that becomes 1. I can simplify this 5 with this 5, and that becomes, again, 1 and 1. So if you look at the numerator, I'm going to have 1 times 1 times 5 times 5, and that's obviously just going to be 5 to the 2nd power. And in my denominator, I'm left with 1. Do I have to write 5 to the 2nd over 1? No, I can just write 5 to the 2nd power, which again is, look, same answer. Okay. Now I'm going to do one where the exponent in the numerator is greater than the exponent in the denominator. So let's do 5 to the 3rd, and let's do 5 to the 7th at the bottom. Let me do this. Okay, so again, doesn't matter. The rule stays the same. Keep the base. Subtract the exponents. And that gives me 5, and that 3 minus 7 is negative 4. So that would be your answer, but that is not the answer that we're going to leave it, because our goal is to not rewrite the expression using only positive exponents. So we're not going to, as far as the example right now, I'm going to leave it as it is, just to show you, but we wouldn't leave this as our final answer. So if we were doing this as a fraction, let's expand it. 5 to the 3rd is 5. 5 to the 7th is 5, 2, 3, 4, 5, 6, 7. We can simplify, right? What's 5 divided by 5? That's 1. This 5 and this 5 also simplifies to 1. And this 5 and this 5 also simplifies to 1. I can't simplify anything else, so I'm done simplifying. So look at the numerator. I'm left with 1, 1, and 1. 1 times 1 times 1 is just 1. The bottom, I'm left with 1, 2, 3, 4, 5 times 5 times 5 times 5. It's 5 to the 4th power. So this is why a negative exponent can be written as its reciprocal, right? And then change the exponent to a positive. These are the same exact values, but same exact numbers, but written differently. Okay, and and this is why we change 5 to the negative power and rewrite it as 1 over 5 to the 4th, because they're exactly the same. Okay, so 3 again. Just in the beginning, the first couple of problems, I will expand it. So we have 9 times 8 cubed, which is 8 times 8 times 8 times 5 b's. 1, 2, 3, 4, 5. At the bottom, we have negative 3a, 1a, and 2b's. Let's simplify what we can. Let's take care of the coefficients, which is the 9 and the negative 3. So 9 over negative 3. So if you just had this, you would say, well, that's negative 3. So this and this simplifies, and we get negative 3. Done. Let's do the a's. Well, this a and this a simplifies to 1. And I can't simplify any more a's. So I'm going to have 2 a's left over in the numerator. In the denominator, in the b's, well, this b and this b cancels to 1. Simplifies to 1. This b and this b simplifies to 1. And what do I have left over? 3 b's. So I'm left with b times b times b. And notice that in my denominator, everything got simplified, and the only thing I have left over is 1. rewrite that again, a little cleaner. I don't need a fraction anymore because there's nothing in my denominator. So my numerator, I'm going to write -3. Well, a times a is a squared. And b times b times b, I can rewrite it as b cubed. So this is my final answer. Now, let me do that problem without expanding it, which is obviously what we want to do. So I'm going to do the same problem. So, coefficients first. 9 divided by -3. Well, it's -3 in the numerator. Now, if you look at, I'll put a little 1 here. If you look at the top, we have 3 a's in the top and 1 a at the bottom. So now if you simplify, right, which is what I did here on the right, 1 of the a's in the top, which is this one right here, it's going to get canceled with the a at the bottom. Where are you going to have leftover a's? In the numerator. How many of them? 2. B5 and B2, how many b's do I have on top? 5 of them. How many b's do I have? The denominator, I have 2. So after you simplify, which is what we did here on the side, this b and this b, this b and this b, you were left with 3 b's left over. And where did you have them left over? Numerator, denominator, numerator. Same exact answer. So again, my suggestion maybe is for you to expand the first 2-3 problems, right, and see what's happening, and then take the shortcut. So here, d to the third power over d to the second. So d to the third power is d times d times d over d to the second, d times d. Well, this guy and this guy will simplify to 1. This guy and this guy will simplify to 1. Well, the numerator, what do you have left over? You have a 1 and 1 and a d. 1 times 1 is 1 times d is just d. In the denominator, you have 1 times 1, and I'm not going to write this over 1, so we can just write d. That's expanding. If you don't want to expand it and you're like, okay, you know what? Start getting this. There's 3 d's on the top, 2 d's on the bottom. After they cross each other out here, or simplify, I'm going to have 1 d left over. And where are you going to have it left over? On the top. Now, if you did it the other way, and you wrote it horizontally, d to the third power divided by d, right? Well, you keep the base, subtract exponents, and 3 minus, so you get 3 minus 2 is just 1. D to the first power. Isn't this exactly the same as this? Okay. Personally, I like doing it this way. I'm not a big fan of this, but it's whichever way they throw it. 9. Let's do 9. Okay, so 9. Ugh. Wow. It's 49 over 7. There's 13 r's. Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There. Over how many r's? 8. 1, 2, 3, 4, 5, 6, 7, 8. For the love of God, just do this a couple of times so you get it. So this one and this one simplifies to 1. These two simplify to 1. These two, these two, these two, these two, these two, and these two. Finally, they all become just one big 1. Now, let's get the final answer. 49 divided by 7 is 7. Where? In the numerator, right? R's. I had 13 R's on the top being multiplied and 8 R's at the bottom being multiplied. Well, after I simplified, how many do I have left over? I'm going to have to look at this group here left over. And I'm not going to write it in expanded form, but I'm going to write it in exponential form. So r to the 5th power over 1. Let's clean it up again. Take one more step to clean it up. Final answer 7 times r to the 5th. And that's my final answer. Oh, sorry, it's supposed to be negative. Okay, because 49 divided by -7 is -7. 12, again, 21 times k to the 9th power over 3 times k times 7 times k to the 4th power. Okay, let's try doing this without writing it in expanded form. So can we simplify anything? Let's see. This is 21. 21 divided by 3 is going to be 7. And this becomes 1. And then we simplify this 7 with this 7, it becomes 1 and 1. So as far as our coefficients, it's just going to be 1. Now, k-wise, I have 9 k's being multiplied at the bottom, and I have 1 k over here, 4 k's over here, so that gives me 5 k. So after you simplify everything, how many k's are you going to have left over? You're going to have 5 k's in the numerator left over. So the final answer to this is just that. Right? So remember, k to the ninth, 1, 2, 3, 4, 5, 6, 7, 8, 9. At the bottom, you had this k over here. Let me write it here. And then k to the fourth, you have 1, 2, 3, 4. Remember, you're simplifying, right? And this is your leftover, k to the fifth power. That was 12. Right. 15, 24, again, 24 x squared y divided by negative 4 x squared. Right, this is easy. 24 divided by negative 4 is negative 6. Done. X squared and x squared, well, they both simplify to 1, right? So you have x squared, which is x times x, and at the bottom you have x times x. This one and this one simplifies to 1. This one and this one also simplifies to 1. So they're gone, and y is the only thing left over. Y, there's no other y's in the denominator. Here we go. Final answer. 18. Okay, so we have a 3 times x times y times 4 times x squared times y, negative 6x y squared. So one thing you could do is rewrite the numerator, right? Simplify the top. That's a suggestion. So let's, in the numerator, let's focus on the numerator for a second. Let's focus on this. Right, let's combine that, make that a little bit smaller. So I can multiply the 3 and the 4, and I can get 12. This x over here and this x squared, so remember x, we're multiplying, so we get x cubed. We add the exponents. And then we have a y times y, and then y squared. Over negative 6x y squared. Right? It's a little bit better looking at that, I guess. Okay. Can we simplify? Well, now we can simplify. Now we can divide. Let me rephrase that. Well, 12 divided by negative 6 is negative 2. We have x cubed on the top numerator. We have x cubed, which is x times x times x, and we have 1x in the denominator. So notice that these two are going to be simplified. How many x's do I have left over? 2. Where? The numerator. And then y squared divided by y squared, well, obviously that goes away because it becomes just 1. Final answer. What was that? 18? Okay. That's multiplying, dividing, and then, power to power, or raising exponents. Okay. So is it this raising? Okay. Now, let's see if we can understand what this means. I'll give you an example here. Let's use 2. 2 to the third power raised to the fourth power. Right? So let's talk about what that looks like. Expanded form. That 4 is telling everybody who is inside the parentheses, multiply by yourself 4 times. So you're going to do 2 to the third times 2 to the third times 2 to the third times 2 to the third. Right? And what we learned before, when we're multiplying, the product rule says that, well, if you're multiplying and the bases happen to be the same, you keep the base and you add the exponents. 3 plus 3 plus 3 plus 3, and we get 2 to the 12th. Shortcut to this was just saying, hey, that's easy. All I have to do is multiply. When you have a power raised to a power, multiply the two exponents over here, and guess what? You get the same answer. This is the shortcut, right? This is our rule, a power raised to a power, multiply the two exponents, or if you want to expand it out, expand it out. Let's do one that's a little bit different. So let's go a squared b third raised to the fourth power. Let's do this the long way. So the 4, this exponent of 4 is telling everybody in the parentheses, multiply by yourself 4 times. So it's a squared b cubed times a squared b cubed times a squared b cubed times a squared b cubed. That's what is happening here. Now, we can, of course, multiply all the ones that have a squared times a squared times a squared times. Let me write them together. So it's a squared times a squared times a squared times a squared. And the b's, b cubed times b cubed times b cubed times b cubed. Well, again, product rule, keep the base, which is a, add the exponents, 2, 4, 6, 8. So I get a to the 8th times b to the 3, 6, 9, 12, add the exponents. So this is my final answer. Now, you're more than welcome to do it this way. But if you don't want to, what does the product rule say? The power to power rule say? Says that if such is the case, all you have to do is take this 4, the exponent that's outside, multiply by every exponent inside the parentheses. So look at what you get. A is going to be 2 times that 4. B is going to be this 3 here times that 4. And if you multiply, you get a to the 8th, b to the 12th. Look, same exact answer. Your choice. Here, all right, so whenever you don't see exponent, put an exponent. Okay, so be careful here because of that negative. So this says, I'm not going to do it expanded way. So it's negative 6 x fourth y6 times negative 6 x4 y6 times negative 6 x4 y6. You know what? Let me rewrite this. I'm just going to deal with it. It's negative 6 x4 y6 times negative 6 x4 y6 times negative 6 x4 y6. That's what's happening here. Now, I can now multiply the coefficients, the negative 6 times negative 6 times negative 6. Now let me leave it in exponential form. Right now, it's negative 6 to the third power. The x's, well, it's x4, x4, and x4. So I have x to the fourth power times x to the fourth power times x to the fourth power, which gives me x to the 12. And then we have y to the 6 times y to the 6 times y to the 6. And that gives me y to the 18. So if it's a, a number with a relatively small exponent, which is in this case, then you can rewrite that. So what's negative 6 times negative 6 times negative 6? Well, first of all, it's going to be negative. 6 times 6 is 36, and then multiply that by 6 is going to give us, I don't know, 18, 216? 216 x to the 12th power y to the 18th. That should be your final answer. Answer. 6, 2, again, remember this is in parentheses, and the 4, because it's telling everyone in the parentheses, multiply by yourself one time. So there's an exponent of 1 and 1. If you do the rule that we're talking about here, right? Power to a power, all you gotta do is multiply the exponent. So we get 2, and I'll put here, it's almost like this tree property, right? 4 times 1 is 4, 2 to the fourth power. X, we're gonna multiply that 4 and that 1, and we get that final answer. Expanded, 2 times x, we're gonna do that repeatedly 4 times. 2, 3, 4. We have a 2 times 2 times 2 times 2. And x times x times x times x. There we go. 9. Okay, again, same thing. We put a 1. So if you don't see a 1, put a 1 there. Might help you. So we're going to get negative 2. Because it's negative, let's put it in parentheses. Negative 2 and 4 times 1 is going to be 4 to the fourth power. Times, and then we have x, and 4 multiplies with a 2. That gives me 8. And the y, what's the exponent of the y? Is 1, and 4 times 1 is going to give me 4. So final answer, well, actually, I can do negative 2 to the fourth power. It's 2, 4, 8, 16, and it's going to be positive because our exponent is even. So it's 16 x to the 8th power, y to the 4th. 12. Ugh, we have all of these 3. Okay. So here, there's nothing to do. Right? And then the second one, we have to do it. So let's, let me write this again. 3 times x times y to the 3rd power. Let's take care of this. Let me put a 1 on top of the 4. So it's 2 is, so that, let me pull this guy here. Negative 4 times x to the 2nd power, y to the 4th power, and that has the outside an exponent of 2. Negative 4 has a little 1 here, so let's multiply. That's going to be negative 4 to the 2nd power x, 2 times 2 is going to be x to the 4th power. And then this 2 is the exponent of 4. It's going to give you y to the 8th. Times, and then the last parentheses, there's nothing to do because, well, there's an invisible one, so that doesn't change anymore. Times x times y to the 3rd power. So you have to take care of the middle factor over here, right, because of that exponent outside, which we did. Now we can take one more step and sort of, simplify this expression. So let's do the coefficients. We have a 3 over here and a negative 4 to the 2nd power. Negative 4 to the 2nd power is 16. Times that 3, you're going to get 48. So it's going to be 48 positive. The x's, I have x here, x to the 4th, and x. Well, there's a 1 here, there's a 1 here. So that gives me 1 plus 4 plus 1, x to the 6th. Y's, I have a y to the 3rd, a y to the 8th, and another y to the 3rd. So keep the base, add the exponents. 3, 8, 3 is going to give me 14. That is what your final answer should look like. 15. So again, put a little 1 here. It's 3. 4 times 1 is going to be 3 to the 4th power. X, well, multiply the two exponents. 4 times 2 is going to give me 8. And the y is 4 times 3, which gives me 12. So that's my final answer. And again, 81, 3 to the 4th power is just 81. X to the 8th power, y to the 12th. 18, 5 times x times y cubed. There's no exponent outside the parentheses, so we don't have to do anything. Times negative 5, I'll put that in parentheses, times x times y to the 2nd power. So this one, fairly easy. Coefficients, 5 times negative 5 is negative 25. X times x is x squared. Y cubed times y squared is y to the 5th power. There is our final answer. Okay. And finally, our last section, negative exponents. Okay, so dividing negative exponents. We'll do quite a few more tomorrow. So negative exponents. So we have to understand, and let's see if I can. 5 to the 3rd power divided by 5 to the 5th power. Right, in division, we keep the base. If it's written in this format, keep the base. Subtract the exponents. And we get 5 to the negative 2nd power. So before today, you're like, I don't know what to do with a negative exponent. Well, let's do this written in a fraction format, because that's going to help us understand how I can fix this to something that I can actually work. 5 to the 3rd power is 5 times 5 times 5 over 5 to the 5th, which is 5 times 5 times 5 times 5 times 5. So now, if we simplify, right? This and this simplifies, this and this simplifies, this and this simplifies, all simplifies to 1. So in the numerator, I get 1 times 1 times 1, which is just 1. And at the bottom, I get 5 to the 2nd power. Now, because they're the same problem, they have to give me the same answer. They both, so therefore, they both have the same value. So this is just showing to you that 5 raised to the negative 2nd power can be rewritten as its reciprocal, but with a positive exponent. So 5 to the negative 2nd power. So if you have something to the negative power, all you got to do is put it as a fraction. Okay? Under 1, right? 1 is the denominator, reciprocal, and 1 over 5, and just make sure to change the negative exponent to the positive exponent. That's it. Okay. Now, if you had something like this, what about if the exponent was at the bottom? What if it was like that? Let me change that to a 2. Now what? Well, it's the same thing, except that let's take it one step further. So if it's a negative exponent, which in this case here, you were told just now to write it, to use its reciprocal. So we're going to take that and write it as, let me change colors, 1 over, right, 1 over 5 to the 2nd power. So I took the 5 to the negative 2nd power, wrote it over 1, sorry, under 1, right, and change the negative to a positive. Now, I'm not going to leave it like this because it's a complex fraction. So, but remember what you learned in when dividing fractions. So this is a division of fractions. So it's when you divide fractions, you're going to change that to a multiplication problem. So it's 1 times, and again, we're going to take the multiplicative inverse of this, and we're going to do the reciprocal of 1, 5, or 2, and go 5 or 2 over 1. And this simplifies to just 1 and 1, and you're left with 5 to the second power. So notice what happened. So when the negative exponent is in the denominator, it goes up. It goes up to the numerator. When the negative exponent is the numerator, guess where it's going? I mean, I guess in very simple language, it goes down to the denominator. So a to the negative third power. How do I change that to positive? Well, write it over 1, under 1. Done. Again, 7 to the negative eighth power. Well, 1 over 7 to the eighth. Change the negative to positive exponent. That's it. That's your shortcut. Right? Because remember what we talked about, this is the same thing as this, but just written in a different manner. Now, what happens when it's in the denominator? So let's say 2 to the negative ninth power. How do I change my negative 9 to become positive? Well, my negative exponent's in the denominator now, so let's take this and throw it up. Ta-da! Done. 1 over a to the negative 3, b to the negative 4. Well, they're both negative, so we're going to throw this guy up. And this guy's going to go up again. Done. Right. We only switch, throw, and move them up or down the numerator, denominator if they're negative. So if you have something like this, a to the negative third, b to the second, and you're rewriting this expression so that it doesn't have any negative exponents. So, well, the b to the second we don't touch because it's positive already. But a to the negative third is going to come down. Reciprocal and a to the third power. Yeah, change it to positive exponent. 3. So 3 times a to the fourth and b to the negative third. Well, 3 is okay. A to the fourth power is okay. There's nothing to do anyway. But b is raised to a negative third power. So that, we're going to go and say, hey, you go down and make yourself positive. There, final answer. Okay. 6, we have 3 times x times y. So, to the negative first power. So now, remember, this is 1, this is 1, and this is 1. So that's going to change in a second because, again, we just did this. Well, power to a power, we're going to multiply. So if we multiply 1 times negative 1, it's going to give me negative 1. X is 1 times negative 1, it's going to give me negative 1. And the y also is going to give me negative 1. Right, so you apply the rule where the expanded rule, right, where you multiply the exponent times all the exponents inside. You get this. Can't be your final answers because you still have negative exponents. But remember, let's take this bit by bit. Let's take care of this. 3 to the negative 1 power is going to be 1 over, and there you go. And now we change that negative power to a positive there. X also, we're going to throw them downstairs. We're going to change that negative power to a positive power. And the y, same thing. So just a little cleaner. That's my final answer. 9, negative 2, negative 2, x to the negative third power. So notice that this negative third power is only being applied to the x, nobody else. Negative 2, there's absolutely nothing to do with negative 2. So leave it as it is. Well, you probably realize that x is raised to a negative exponent, so we're going to take that. So again, remember what we do when it's a negative exponent? We're going to turn it to fraction, and this guy goes to the denominator, and exponent becomes positive. So again, the 2 stays up, but the x to negative 3 is going to go down to the denominator and change the negative to a positive. Okay. 12. So we have 4 m cubed n to the negative fifth power. So we write the expression so that there are no positive exponents. Well, Nothing to do with the 4. There's nothing to do with the m cubed. N to the negative 5th power, right? So now we can turn this into a fraction, and this guy goes down here, and the 5 becomes positive. That's our final answer. 15. I'm going to do 15. So 15, what's 15? 14. Uh-oh. No. What's going on? 14x to the negative 8th power times y. Nothing to do with the 14. Leave it alone. X to the negative 8 is negative exponent, so we got to change this to a fraction, and this guy is going to travel further south, and now the exponent is negative. And the y stays exactly where it is because it has an exponent, a positive exponent, 1. That's it. 18 is an interesting because it's a fraction. Right, now let's do this the long way. Let me put a 1 over here and a 1 over here. When it's a fraction, well, first of all, let's multiply. So this multiplies, right? So negative 1 times 1 is 2 to the negative 1st power because we're using the expanded rule. And then we're going to multiply the negative 1 with the 1 of the exponent of the 3. So this is what we get. Now, we know that this can't stay like this. So here's my fraction. And this guy, where does he go? He goes down. And his exponent becomes positive. And 3, which was negative to the negative 1st power, was in the denominator. Where is he going to go? To the numerator with the exponent of 1. So my final answer is 3 to the 2nd power. Now, the quick way, or the more direct way of doing that, right, is, remember, when it's a fraction, you can just use the reciprocal, 3 over 2, and make the negative into a positive exponent. So let me give you an example. 3a squared, 3a squared over 5c to the 3rd power raised to the negative 2nd power. So there's a couple of ways you can do this, but if the first thing you want to do is like, I hate having this negative exponent here and you want to get rid of it, well, change it to positive. And because you change to a positive, you're going to have to use the reciprocal of this, and then 5c cubed, 3a squared comes down to these two. The numerator becomes the denominator, and the denominator becomes the numerator. And here is y, right? So if you decide this, that's the quick way, but let's say you don't want to do the quick way to like, I actually want to multiply. So if you use the expander rule and multiply this negative 2 times this negative 2 times 2, this negative 2 times the 3, and this negative 2 times the 1, let's see what you get. You end up getting 3 to the negative 2 power, right, 2nd power. A, 2 times negative 2 is negative 4. B, B, 5 to the negative 2nd power. And C to the negative 6th power. So notice that everybody has a negative exponent. So let me just, right, so we get 3 to the negative 2nd, A to the negative 4th, 5 to the negative 2nd, and C to the negative 6th. So, right, I'm going to erase this, I just moved it to the side. Now, everything in the numerator is negative, everything in the denominator is negative, so 3 to the negative 2 end up going here. A to the negative 4 goes to the numerator, but we change it to positive. 5 to the negative 2nd power goes up, we make that positive, and C to the negative 6th power goes up and becomes positive. This is the same thing as doing that. Well, except that we didn't do this yet, the multiplying yet, but you'll notice that 5 to the 1st power times 2 is 5 to the 2nd, C to the 3rd power times 2 is C to the 6th, 3 to the 1st power times 2 is 3 to the 2nd, and A to the 2nd power times 2 is A to the 4th. It's really up to you how you do it. It's really, really up to you. So again, let's do 4 to the 3rd, A to the 2nd over, I don't know, x to the 2nd power y. And all that raised to the negative 4th power. Option 1, take care of this negative 4, make it positive. Well, okay. Sorry. You're going to make the exponent positive. So the negative 4 is going to become 4. But if you do that, then you got to change the numerator, the position. The numerator and denominator have changed position. So the denominator becomes numerator, and this, the numerator becomes denominator. There. And then now you can multiply these, right? And then the advantage is that this 4 is no longer negative. And if you did that, you get x to the 8th, y to the 4th, 4 to the 12th, 8 to the 8th. That's. Now, let me change colors, and you say, I don't want to do that. It sounds a little bit too complicated. Well, then don't. I want to do this. I want to take that negative 4, and it's almost like a distributive property. Right? You multiply negative 4 times every exponent inside the parentheses. That's a wonder, by the way. And if you do that, you get, well, let's do it. 4, 3 times negative 4 is negative 12. 8 to the second times negative 4, 8 to the 8th, negative, over x to the second, but it's 2 times negative 4, you get negative 8. And then y to the first times negative 4, you get y to negative 4. Well, still not done because everything has negative exponents, right? So if you do one at a time, 4 to the negative 12th power, well, you're going to throw him down here and make the 12 positive. 8 to the negative 8th power, the exponent is negative, so he's coming to the denominator, and the exponent becomes positive. This, x to the negative 8, is negative, so shift them upstairs, and that becomes positive. Y to the negative 4th, it's negative. Negative exponent, so we shift them up. It becomes positive. Look at these two answers. They're exactly the same. Which path you want to take, it's really up to you. All right, so that hopefully helps a little bit.